Okay, in today's video, I'm going to go through a couple of quick examples about how we calculate the capacitance of a capacitor. In a previous video, I went through an explanation of this equation, the one we're going to use to calculate the capacitance of a capacitor, and the factors that affect the capacitance of a capacitor. But in this video, we're just going to go through a couple of quick examples. The other video you can link to in the description of this video. Okay, here we go. We have a capacitor. It says calculate the capacitance of a parallel plate capacitor whose plates are 20 centimeters by 3 centimeters. We'll assume they're rectangular and they're separated by a 1.0 millimeter air gap. We want to calculate the capacitance of the capacitor, so we're going to get out the equation. This is the equation we're going to use. This is the capacitance equal to the dielectric constant times the permittivity of free space divided by, or multiplied by the area divided by the distance. Now in this problem, there's no mention of a dielectric. There's mentioned air. Air has a dielectric constant of 1. So there's basically, we kind of think about it as not having a dielectric. So when there's no dielectric, this value K is 1, and we often just rewrite the equation like this because any number times 1 is that same number. So we kind of simplify the equation first. You don't have to. You can put 1 in here for the dielectric constant of air. But I'm going to use this equation. We know the constant because it's a constant. We know the area. We know the distance. We can calculate the capacitance. We have our permittivity free space. It's a constant. It's always this number, 8.8 times 10 to the minus 12. Coulomb squared divided by Newton meter squared. There are different units you'll see for this constant. Sometimes you'll see it as a farad meter. But I think this is one of the most common. Maybe farad meter is equally as common, but we're going to use this. Then we're going to multiply that by the area divided by the distance between the plates. The area we're going to calculate right here, we have 20 centimeters, which is 0.2 meters. We have 3 centimeters, which is 0.030 meters. Divide that by the distance is 1 times 10 to the minus 3. That's millimeters, because it says right here millimeters. We have to convert everything to meters in this case. And then we're going to just simply multiply this by this divided by this. And we get that the capacitance of this capacitor is 5.3 times 10 to the minus 11 farads. These units work out to farads, which is a coulomb per volt. Okay, so that is our first example without a dielectric. Okay, we'll do one with the dielectric, of course, and we're going to calculate the capacitance of the capacitor. Consists of 2 round aluminum plates. Each has a radius of not 0.5, but 5 centimeters. The plates are separated by a piece of plastic. That piece of plastic is 25 micrometers thick, and that plastic, which is the dielectric, has a dielectric constant K of 2.2. Okay, we're going to get out the same equation. In this case, we have a dielectric, so I'm just going to leave K here. Remember the previous one, K was 1. In this case, we have a dielectric constant because we have a dielectric, and we just plug the values in again because we were given the area, we're given the distance. So it's 2.2 times our constant, 8.85 times 10 to the minus 12. We multiply that by the area divided by the distance. The area is, because they're round, that's round, radius, round plates, pi r squared, pi is pi. This is the radius, 5 centimeters is 0.050 meters. Everything has to be in meters squared. Divided by the distance, this is 25. Micro is 10 to the minus 6. I wrote 25 micrometers. Everything has to be in meters, so the units cancel properly with our constant of proportionality. And if you multiply this times this divided by this, you get that the capacitance of this capacitor is 6.1 times 10 to the minus 9 farads. Okay, there you go. There's 2 quick examples, one with and one without a dielectric. I think that's pretty straightforward. Just plug the numbers into the equation. Make sure you convert everything to meters and you get the correct units first. And I think you can do that no problem. Okay, so thank you very much for watching. I hope you found that video helpful. If you did, please do all the following 3 things. Give me a nice thumbs up for this video. Give me a nice comment in the comment section below. And also very nicely subscribe to my channel. Get all my excellent physics, chemistry, and math videos. Thank you very much for watching. We will see you in the next video.